Next, let's see solving system of equation using matrix. So let's learn about elementary row operations, or we call it ERO. Okay, so in doing elementary row operations, there are three operations that you can do. The first one, we can interchange the rows. Okay, so you can just write R of that number of rows and you just exchange using this symbol with another row. The second one, we can multiply the row I by scalar k. Okay, so you can take any number of k, multiply towards the whole row, and then put it into the new row. So this R here is small, so representing the old row, and this R here is capital R, so this is representing the new row. And the third operation that we can do is we can add k times of row I to row j. So we can write it as k ri plus another row rj, and then let's put it at the new row rj. So this is a standard way to write matrix, plus rj, put at a new rj. Now let's see here, the first step when we want to do ERO is you must know how to do augmented matrix. So what's the meaning of augmented matrix? It is adjusted matrix. So from this equation here, okay, you can write it as a matrix. So from the system of equation here, you can write it in terms of matrix. So this is actually 1, 3, 2, minus 1, multiply to xy equal to minus 1, 5. So this is the matrix that we can build here. So 1, 3, 2, minus 1 comes from the coefficient of each of this number here, and then multiply towards your variable x and y, and then equal to this part here, negative 1, 5. So if you open up row times column, this is 1x plus 3y. So this is equal to negative 1. How about the second one? This is 2x minus y equal to 5. So you'll get this form back. So what's the meaning of augmented matrix? The meaning is we just take this part here and then make a straight line as a separator, and then put this part here, negative 1, 5, okay, the right hand side. So no need to put x and y because we already know this column stands for x and this column stands for y. So this is very clear to us. So that when we want to do ERO, we can just focus on the numbers here without any variable. Now let's see for this question here, if you open up as a matrix, this is 1, 1, 1, 0, 1 minus 3, 2, 1, 5, multiply to x, y, z, and then it is equal to a matrix of 2, 1, 0. So we can take it and then put it in augmented matrix. So just open up and then put the coefficient here and make a separator here, and then let's put the right hand side here. So this is an augmented matrix. So there are two methods that we can follow. The first one is Gaussian elimination method, right, where we want to change our matrix to become echelon form. So what's the meaning of echelon form? This means the number under the diagonal part is all zeros. Okay, so another way is to use Gauss-Jordan elimination method. So this is using the augmented matrix reduced to reduced echelon form. So what's the meaning of reduced echelon form? We want to make all the diagonal part is 1 and all the other entries here are zeros. In Gaussian method, first we want to make this number to become 1. And then the second step, we want to make this 0 and this part here 0. The third step, we want to make sure this is 1. And then the fourth step, we want to use that 1 to make this part 0. And finally, we want to make this number to become 1. So this is the method of Gaussian elimination method. How about Gauss-Jordan? In Gauss-Jordan, what we aim to do is we want to make this first row and column here to become 1. Then we want to use that 1 to make all the numbers down here 0. Third, we want to make this 1. And the fourth step, we want to make this 0 and another part here 0. Fifth part, we want to make this 1. And for the sixth part, we want to make all of these 2 here 0. So these are the steps that we need to follow in order to do Gauss-Jordan elimination method.